In a particular year, registered nurses earned an average salary of $52.30. So that's your population mean, 52,330. A survey was conducted with 44 nurses, so N equals 44 from a particular state to determine if the annual salary is higher than 52.30, so greater than 52,330. The sample average, so for the sample, X bar, that's the sample average. The X-bar sample average is 61,585 with a sample standard deviation of 7489. Conduct a hypothesis test where alpha is 0.05. So your null is, so the equals is not showing, so this is your alternative, HA, this is your null. The opposing view to greater than, so higher corresponds to greater than. The opposing view for greater than is less than or equal to 52,330. So it's going to be this one. And the alternative is greater than 52,330. So it's going to be this one. And we're going to write down, we need this data for StatCrunch to find the p-value and the test statistic. Okay, so if you, part C, what is X bar? X bar always stands for average. So X bar is the average annual salary of nurses. So it's right here. And then the distribution, since the population standard deviation is not known, so sigma, the population standard deviation is not given, and we're not dealing with proportions where the NP and NQ are greater than 5, then the distribution is going to be a T distribution with 43 degrees of freedom. Degrees of freedom is n minus 1. So that's going to be 44 minus 1, which is 43. Because we talked to 43. Because we talked to 44 nurses, so there's 43 degrees of freedom. The test statistic is going to be T. It would be Z if we were using the normal distribution, but since we're using the T distribution, it's going to be a T statistic. We go to StatCrunch, and we go to Stat, it's T stats. One sample with summary. So the sample mean is 52,330. Your sample standard, or no, actually, that's your population. So your population is 52,330. Your sample mean is your X bar, which is 61,585. The sample standard deviation is 7489, and the sample size is 44, and our HA is greater than, and then we compute. So our degrees of freedom we already figured out was 43. Our standard error we actually don't need, but it's 1129. And our t-stat is 8.20, and our p-value is less than 0.0001. So our test statistic is 8.20. Our p-value is less than 0.001. So 0.0001. 0.001 is less than 0.010, so this is our answer. This one wouldn't work, 0.0001, because 0.001 is not in between 10 thousandths and 50 thousandths, right? Or between 50 thousandths and 100 thousandths, or 0.1 or 1/10. So this is our answer. Explain what the p-value means. The p-value actually always has the same meaning for these problems, and it's if H0 is true, then there is a chance, so we definitely don't want the false ones. If H0 is true, then there's a chance equal to the p-value that the average annual salary for a nurse is 61,585. So this is it. The idea behind that is you have your population, which is 52,330, and your standard error, right, it was, I think it said 1129, so you could calculate your test statistic by doing 61,585 minus 52,330 divided by the 1129, and you would get something close to 8.20. So this is the population mean, and our result, 61,585, is 8.2 standard errors above the population mean. So if H naught is true and the true population mean is actually 52,330, then there is a 0.0001 chance of getting this result or more extreme. So maybe we just happen to survey a bunch of nurses that make more money, even though that the population mean is around 52,330, and we just happen to survey nurses that make that large amount. But that is, it's possible, but it's highly unlikely. What's more likely is that the population mean is not actually at 52,330, but much higher. Because to get a sample of 44 nurses and their average to be that high, it's more likely that the population mean has shifted and it's higher. So the picture that you would need for this, you can upload any Word document, but if on the test, if this was on the test, the picture you would want to draw is your population mean here and your 61,585, and we're shading to the right. It's a right-tailed test because alternative, this is all based off the alternative. The alternative says that the population mean is greater than 52,330. Our alpha is our significance level at 0.05. Decision. So if the p-value is low, the null must go. If the p-value is high, the null must fly. Our p-value was 0.0001. So if the p-value is low, and what is the threshold for considering it low or high is your alpha. So anything under the 0.05 is considered low. Anything above is considered high. So since ours is low, the null must go, which means we reject the null. And so if you're rejecting the null, you're favoring the alternative, which means that you're concluding that there is sufficient evidence to suggest that the average salary is more than 52,330. And we want to reject the null. So it's one of these, okay, because we're definitely not it's not one of these. Our decision was to reject. Now to determine which one it is, your alpha was 0.05, your p-value is 0.001, and 0.05 is greater than 0.001, so this is going to be our answer. Construct a 95% confidence interval. So the confidence interval is based off your sample. Your sample was 61,585. To construct the confidence interval, we did that by hand, but for this test we can use StatCrunch, go to Options, Edit, and then we're doing a confidence interval, and it's 0.95, and you see it's the confidence interval is based off this data, your sample, and then you compute, and you get 59. It wants us to round to the nearest whole number, so 59,308, 63,862. So we have 59,308, 63,862, and what the 95% confidence interval means is we're 95% confident that the true population mean for the average annual salary of nurses is between 59,308 and 63,862. And you see our population mean 52,330 is actually not in this confidence interval. So that's another reason why we can, that points to the fact that we're rejecting the null and accepting the alternative.